Okay, so I'm the only thing that stands between you and lunch, so I'll be quick about it. So what I'm going to talk about is BPQ. BPQ is basically the workhorse that makes most of the digital systems work other than RMS itself. So strictly speaking, what it is a NetROM compatible packet switch. I had to read it off from the slide because I can't say that really fast. But it's basically the infrastructure that ties all of your digital modes together. So the idea is that you can have, let's say, a PACTOR modem, a packet modem, have different packet modems on different bands. And what BPQ does is to tie all of that traffic together and take stuff from one port in and send it out over the other port. It almost acts like a router does in the IP world. Again, it's a switch, so it basically does the forwarding of the packet messages. It doesn't do any of the individual protocols itself. To talk each of those protocols, you're going to have either hardware, such as a PACTOR modem or a packet modem, to actually do the translation, or you have to have software, such as VARA or something like that, to actually translate the digital signals into either sounds or signals that can go out to your different devices. But also built into BPQ are some features such as a BBS, so it can act as a standalone BPS. It's not just a switch between the various things. So when you connect to an RMS, 9 times out of 10, you're actually going to be talking to a BPQ station in the background. So it's basically, it acts as an access point for all of these different kind of modes. But it doesn't just have to be a way of connecting to, for example, WinLink. It can also just be a way of transferring messages from one station to the other. So here's an example of a device we had up on Mount Thornton during the Dirty 30 a few years ago, when we were still primarily relying on packet. So we've got 2 radios, 2 TNCs. In this case, it happens to be a BeagleBone Black with the TNC black on it. And the one was on VHF 14499, and the other one was on UHF 434.125. And so what you would do is you would dump in your message on the VHF side. It would store that message, and then through the configuration that says, once I know where that is going, the internal configuration say, oh, what I need to be doing with this message is send it out the UHF port and, for example, forward it to the trailer. So then it just goes out the other side and gets forwarded that way. So that kind of cross-banding, not through the traditional digipede, right, where you do it a packet at a time. What BPQ really is best for is doing it a message at a time. So you send the message in, the entire message gets stored, and then the entire message gets forwarded. But you can also, of course, at the same time, use it as a BBS. So this can actually be the place where the messages stay, and people just connect to the BPQ node and pick up the messages as need be. As I've mentioned before, this is also very popular for radio message stations. So BPQ also has a Telnet device where you can, via Telnet, connect to the CMS and either upload messages or download messages. However, because AX25 is used for a bunch of other things, such as, for example, APRS, you can also make one of the ports on your BPQ node an APRS gateway. So it will basically, in a receive-only mode, just pick up all of those messages, position messages, and forwarded them to, for example, APRS.phi. Or you can make it an active transmitting APRS station where it will actually echo back out all of those packets. If I have time, though, there's actually a really interesting way that you can use this, which is an application gateway. So one of the unique features of BPQ is that you can write your own application, right? So let's say you want to re-implement WinLink. What BPQ allows you to do is have people connect to the BPQ station over RF, and then on the back end, it connects to whatever application you've just written, and that application processes that traffic or serves up traffic, however you want to do that. So how does it work? Well, of course, it's just software. So it runs on most computers, but I will admit to being an open source bigot. So I don't do Windows. So I only do BPQ on Linux. And most of the time, I'm going to do it on a Raspberry Pi just because that's what all the cool kids do. The big problem with BPQ is that because it is so flexible, it leads to futility, right? The configuration file is really, really complex. And so getting started with BPQ is a really daunting task. So what we typically try to do is use a program like bpq-config to just get the thing going, talking to all of the different devices, and then once we've got it, the basics working, then we start messing with it so that when it breaks, we can go back to whatever used to work last and work from that particular point. So in between the BPQ node itself, which is of course a piece of software that runs on a device such as a Raspberry Pi, you have to have the terminal node controllers. So in this case, we've got two TNCX versions here. The one shown in red is the 1200 baud version of the TNC. The one that is in blue is the 9600 baud version. And both of these will just connect directly to the radio to then, do the transmission. But of course, there's also USB ports on here, right? So if you want to connect to a Pactor modem, you would use a USB to serial conversion to talk to the Pactor modem, or some of them are, of course, natively USB. And then the other modes, such as VARA, if you want to connect to a VARA device, you do that over TCP. So there's your Ethernet port. So as long as you can talk to the device to actually do that transmission for you, BPQ will do that just fine. The other thing that's very nice about BPQ nodes is, for example, I run one, John runs one, Jeff Carrier runs one in Canyon City, Joey runs one up in Longmont, James Sizek runs one up in Fort Collins. And because all of these devices are actually on the RMHAM backbone, those BPQ nodes can talk to each other over something called AXIP. So it's basically AX25 packets encapsulated in UDP packets. Now you can do that over the commercial internet, of course, but the way that we interconnect those is actually over the RMHAM microwave backbone. And so once those nodes are talking to each other, you can send data in on one BPQ node and go out on another BPQ node, just like you would have been hopping from one node to the other on RF. So works out pretty well. As I've mentioned initially, BPQ have always been hard to set up. The running joke is that there is only one BPQ configuration file that was originally created by John Wiseman, and everybody else has just taken that configuration file and modified it. Because there's just so many options in there that 2/3 of them I have no idea what they do, but you just leave it at what it was when you got it and don't mess with it. So what I did was to write a program called bpq-config, which will help you just customize that basic standard script that I stole from John to just fill in things like your call sign, the specifics of your particular station, and then get the basic system working. Then once you have it basically working, there is also a web interface to it. So you've things like, for example, the message forwarding. is actually configured through that web interface. It has a bunch of double negatives in it, so really watch what that interface actually does, but it is a little bit easier than just modifying that text file. But I would strongly encourage you to join a support group if you're going to use BPQ, because it can be an exciting experience.
To give you a call, Willem.
So BPQ, of course, is named for John Wiseman, G8 BPQ. He's still around and still actively maintains it. Writes somewhat C code that I don't really care for, but it works, so I'm not going to complain about that. Originally, it was called BPQ code, and it was just a DOS program, 8-bit DOS program. And then in the 90s, he converted that to BPQ32, which was just, essentially what we're using today. He ported it to OS X and Linux in the 2000s, and in about that same time frame, ported it to the Raspberry Pi and the BeagleBone Black. So that's the versions I particularly care for using, and it's open source, so you can grab the source code if you need to. So if you want to actually set up your own RMS station, or just a bulletin board station, what I would recommend is you grab bpq-config, you just download it, create a directory called bpq, or whatever you choose to call it. bpq creates a whole bunch of files, so you don't want this in your home directory, it'll just clutter it up. You download bpq-config, do a change mod on it so that it becomes an executable, and then you just run bpq-config. If you do this on a Raspberry Pi, I've had a running battle with the folks that actually run the operating system because they keep on messing with things. So where the serial port ends up being is different with every new version of Raspbian OS that comes out. So, and the other thing that they did was when they enabled Bluetooth, the Bluetooth grabbed the serial interface. Well, we wanted the serial interface. We don't want Bluetooth. So what bpq-config is going to do at first is just disable a bunch of stuff that's just going to create problems. It's a little aggressive at doing it. So it'll actually turn off stuff that you don't necessarily have to turn off. But since I get the support emails, I just turn it off. And if you turn it back on again, it's your problem. Don't email me about it. So what is primarily going to turn off is the Bluetooth and the serial access to the, or the Getty access to the serial port. And it'll basically go and change the configuration file of the Raspberry Pi. And then when you reboot, then it'll boot into a clean version that you can then mess with. So the first thing to do is typically the quick install. So there is an expert mode, which is not all that much more difficult to configure. But if it's this your first time, I would just say just do the quick install, and it'll get you going. You'll have a working setup, and then you can break it afterwards. So what the quick install asks for is the name that the call sign that you're going to associate it with this. An owner acronym, because it will also set up these tactical calls. Like, for example, if you put in CTL for Colorado Traffic League in this case, it'll actually create a tactical CTL BBS that you can connect to as a quick way of getting in there. The owner name is used in the broadcast messages so that we can know who this is. It'll ask for your grid square, just because that grid square is typically shown in the broadcast message. But if you set this up as an RMS gateway, it's also going to report that to WinLink. You tell it what frequency you're going to be on, and then you put in a username and password for basically the system operator. And you're going to use this to connect over Telnet to that node so that you can set up the various functions that you need to do for the WinLink the mail forwarding configuration. And then if you want to use this as a WinLink RMS, then you select the WinLink RMS to yes, and then it will add those 2 new lines at the bottom where you then put in your WinLink call sign and your WinLink password. And so, of course, if you're going to run an RMS, John already alluded to this, you need to first get authorization from the WinLink system. You can put stuff in there, it just won't work. So once you get that authorization, then this will work. And what bpq-config will do is also set up reporting to the WinLink system so that when your system basically comes up, it will show up in the RMS database that WinLink has. So once you've done that, there's a couple more screens that it walks through to actually configure things. But basically, you've now got a running BPQ node, and it tells you the IP address and the port number, and it defaults to port 8008, that you can just point a browser to, and you should see the BPQ configuration screen. You can also connect to it just via Telnet. So what you would have to do is Telnet, the IP address, and then the port number. And again, there's a default port 8010 that we set up. And once you've done that, you should be able to connect right into your BPQ node. The other thing, of course, that you need to do is actually do some configuration of the port. So in the quick install, it will default to the first serial port, and it will set it up as a 1200 baud packet station with the frequency that you entered. So you can go and see what that actually does by, in this screen, which is the main control screen, to go under Configure BPQ, go to Port Configuration, and then go to the first port, which is the default one, and you'll see that it basically gets populated with the stuff that you've put in the Quick Start screen. So the type defaults to packet, the device type is serial, and it'll be device 0. So on the Raspberry Pi, there's only one real serial port, AMA 0, and that's typically where you're going to connect to first. And then the frequency is what you've put in as the frequency. It'll default to digipeat. And the WinLink 2K no means that this is not going to be reported to WinLink. If you enable that, it's going to ask you for a few more things to enter. And I didn't want to make that quick start menu too long, so I just defaulted this to 0. If you want to change that, of course, you can simply in the screen change the settings for that first port. Or if you want to add a second port, all you would do is you would go to under port configuration, add port, and then it will add another port. So under that particular settings, you'll see there's a few more lines. The key thing is that I've added report to WinLink where this RMS is. And if you do that, it wants to know what power are you running, how high is your antenna, and what's the gain of your antenna, right? So you have to provide that information because it needs to be reported to WinLink. If you want to set up this port for something else, if you go up to the type, you'll see you can actually configure that port one of 3 ways. You can either configure it as packet, which is the default, or you can configure it for APRS. And under APRS, you can either have it as a transmitting APRS station or a receive-only APRS station. If you set it for receive-only, all it will do is it will receive the packets, report them to APRS PHY. If you actually set it to transmitting, then it will actually rebroadcast those using the wide protocol to actually configure all of this. If you've set it to APRS, of course, it's going to ask you for a few other things like where are you and so forth. But for the most part, in this case, I'm just going to leave it on packet, and I'm going to set this up as an RMS gateway. Under users, again, we've got a default user. This is the second configuration step, or the third in this list, actually. If you go, just look at me. You put in your username, your password. That is not my real password. And then you set the application. So the application is when the user connects to this BBS, where do you end up? So the BBS actually has a node mode where if you're connected to the node, then you can say, okay, I want to connect to another node on port 4, and then from that node connect to another node to port 7 and sort of work the world. Or you can set the application to BBS. So I'm going to treat this as primarily a BBS. If I connect to, for example, K0 NTS-1, I end up in the BBS. If I connect to K0 NTS-10, it's actually acting as an RMS, and I will connect out to the WinLink system. So this is just the default for when the user actually connects to it. And then the final one is just if you're a sysop, if that's ticked on, then that user has the ability to see all the traffic on the node and make modifications to it. So for example, re-forward messages and things like that, whereas most users would not be considered system operators. And then the last thing that we may want to configure is the AXIP node maps. So what AXIP allows you to do is have multiple BBS stations, BPQ stations, I beg your pardon, that actually can talk to each other over UDP. So what you would do there is you would go, and there is no defaults here, so everything that you're going to do is going to be additions. So you can add a new map, and essentially all you do is you add a call sign. In this case, I'm putting in Joey's here, NV0N, and I tell it how I'm going to get to NV0N is I'm going to go to that IP address and that port. Of course, it doesn't have to be an IP address. You can put in a DNS address if you're so inclined. But basically what this will then, what it will do is set up a way where you can see another device by just sending UDP packets to it, just as you would have if you were connected to it via RF. One thing that you have to make sure is that the person at the other side has the appropriate settings to actually respond to you. So there is something called auto add, which means that if I connect to you, I automatically get added to your EXIP map and it'll talk back to me. If you don't have it set up that way, the person on the other side actually has to manually set up that you're an allowed AXIP user, and it'll bridge back to you back and forth before it'll actually properly connect. I used to always just leave everything wide open and just auto connect, and my list got so long and so ugly, I had to disable it. So I've limited it to just, you know, the people on the RMHAM backbone, basically. Once you're done with that, you're basically done with the configuration of BPQ per se. So you would go and say write configuration. If you try to exit out of this without saving your configuration, it will be nice enough to remind you that you're about to lose all your changes. And it will also save a copy of your old configuration file. So if you do this a lot, make sure that you keep on renaming your old files so you can go back to the last one that worked. Because if you break it, you got to fix it. Then once you're done with that, you're back to the main screen. And essentially what it contains is you can update BPQ from this. So there are fairly regular updates, maybe 2 or 3 times a year. If you just do update BPQ, it'll actually update it. Both the bpq-config program as well as the actual BPQ program. Of course, configure BPQ allows you to go back and actually change your configuration. But what you want to do at this step is to restart. And that will basically, you know, load the new configuration of BPQ that you can now run it. There's also stop, disable BPQ start on boot or enable it. And then the most important one is number 6, the status. So if you go back to that status page, it'll tell you BPQ is actually running. Of course, if you really broke the configuration file, BPQ may refuse to start, and then you need to go and figure out what that was. but it'll tell you what the web address is for both the web configuration as well as Telnet. So now that you have the system working, what you need to do is to actually set up the message forwarding if you want to do that. So this is the BPQ interface from the web. In the top left-hand corner, I have that red box. So you're basically going to point it to the IP address and the port of that particular node, and it should give you a page that looks like this. And all of these windows up here allows you to just do all of the different settings. So in this case, you'll see that I have 2 devices connected. Async is basically the serial port that's on 145050 and running 1200 baud, and the UHF connection is over I2C on 441075 running 9600 baud. And then I've got the Telnet server. That's basically all of the IP connections. And then lastly, I have the AXIP connections, which is basically the interconnection between all of the BPQ nodes. On the configuration page is where you're mostly going to set up your message forwarding. And this is where there are so many double negatives, you really need to think about whether things should be on or off. So for example, don't hold messages from new users means send messages from new users. So if you want a new user to actually be able to send messages, you have to say don't hold. Say no more. So bpq-config will actually set most of those defaults for you, so you don't really have to mess with it. The main thing that you may want to add here is this H route, to the extent that our digital infrastructure is kind of really broken, so it really doesn't work very well anymore, but put in your route there. So Colorado, USA, North America is something that you can add to that. But then the forwarding is really where things get interesting. So here, for example, I've switched BBSs on you. This is the K0 NTS forwarding for the NTS digital system. And basically what I do is I forward my traffic to all of the NTS regions, so Alaska, Alabama, Alberta, Arizona, and so forth. I forward to K0 FBS, but in order to connect to K0 FBS, I have to do 2 hops. So the first thing I'm going to do is I'm going to go to port 2, which is my UHF port, and connect to Wayne W0ARP on -7. And then from him, I'm going to connect to K0 FBS on Wayne's port 4. So by simply adding those 2 lines in there, it knows that, okay, to get to Brian, I need to go to Wayne, and from Wayne to Brian. And then those are the 2 commands that it needs to execute. And it'll actually figure out all of the handshakes and read the results to make sure that that all works. All of that traffic is going to get forwarded. And basically what we say down here is go check for new mail every 3 hours. But if you have outgoing mail, just go and send it right away. That's what this line here means. A message is limited to 10,000 blocks. And in this case, since we're just talking regular packet, we're actually using the B1 protocol, which is a regular AXIP or AX25 protocol. And so that kind of setup we will do for each of the stations that we want to be able to forward traffic to. To forward traffic to WinLink per se, I don't really need to do anything special. So in this case, I have a certain number of call signs that I send traffic to all the time. And so if I want to get something to Lauren in 1IQI, I can just go in my BBS and just say, send it to 1IQI. And what this forwarding says is, if this BBS receives traffic for N1IQI, it's automatically going to forward that to WinLink without me telling it that it needs to go that way. On the other hand, if I were to connect to it and I say send it to N1IQI at WinLink, then it will basically know that it needs to send that traffic out to WinLink from this BBS. So traffic that is actually on this BBS gets forwarded this way. The other way that you can, of course, connect to this device is just to go to the -10 port, and it actually then just adds as a forwarder, right? It basically just takes any packets that you send, forwards them directly to WinLink, and WinLink responds to you so that the BPQ station really doesn't get involved in that transaction at all, other than forwarding your packets. Of course, the other thing that you can do here is, in this case, KB1SGJ used to run a BPQ or just a KPC node, and he wanted to have all of his WinLink traffic downloaded to his KPC. So the way that I set that up was to say, in this case, you know, between those hours, just connect to KB1SGJ, and if there's any traffic for KB1SGJ, then just forward that directly to him. In his user page, which that was one of the slides I shouldn't have deleted, Doug, but you made me delete all the slides. I would have just clicked on download from RMS all of the traffic for this particular user, and the BPQ node will connect to the RMS every, you know, what period you said, download all of the traffic, and then forward it to this individual KPC if you set it up that way. So the one thing that I wanted to stick in here, and I won't belabor the point, but even though it's really nice to use WinLink, which gives you sort of or WinLink Express, I should say, which gives you a really nice email Outlook-like interface, this all works still with the old connect with the KPC and type stuff directly at the terminal way, right? So I can connect to this BBS. In this case, I was using an N0SZ call sign for one of these. You can simply connect to it and type stuff at the command line just like we did back in the 80s, right? And it will still respond to that. So you can do the info, the ports, the BBS, and get all of the traffic out that way. If you're dealing with NTS traffic, most of the time we still have to do things this way because WinLink doesn't do great with NTS traffic. The reason essentially is that NTS traffic is typically not directed at a particular user. It's directed to everybody in the zip code. And so what you need to do is connect to it and say, hey, show me all the messages that are out there, and I'll pick which one I will take, as opposed to the typical way that we would use WinLink for, which is just give me my email, right? So that this use case is a little bit different. In this case, what I actually wanted to show is that you can actually connect to WinLink directly using just a regular Telnet or a RF connection from the keyboard. And this will go over Telnet from here, from the BBQ node to WinLink, but your RF into here. What you'll just have to figure out is how do you tell it what your password is? Because obviously, if you type in your password over RF, everybody's going to know your password. So the method that is used is it'll give you a challenge, in this case 246, and what it says is you need to send me back a string where the second, the fourth, and the sixth character of your password is in that string, but you can send any random string, and as long as those 4 magic characters appear in that string, I will authenticate you. Now, obviously, this is not terribly secure, but you know, we're hams. We trust each other. It's just those bastards on the internet that we have to worry about. Enough said. And of course, in this case, I just wanted to demonstrate that you can also do this node hopping thing, right? So in this case, I'm actually connecting via RF to N0SZ. From N0SZ, I connect over port 3, which is the AXIP port, to K0 NTS. from K0 NTS, I can connect on port 4 to W0 ARP-7. You can go as long as you want. You're sort of walking the chain. And I've done this where some of these are HF links, some of those are VHF links. As you have more and more links, things really tend to slow down. But, you know, if you really have to, it's doable. The last couple of things that I want to show you here is just if you use the APRS mode for BPQ, you get a page like this. The interesting thing about this page is that some of these stations it is heard by RF. Some of it actually talked to APRS PHY and gave you a bunch of stations that are close by, and it figured it out over IP. So in this case, I wanted to know, where did Doug take the QRV? And it says, yep, it is right there at Doug's house. So you can basically, here locally, check on the location. It'll show you a Google map with that. Or, of course, it'll report this information to APRS PHY, and you can get to the information that way. So I'm sort of out of time here, so I don't want to keep you and belabor this point, but I'll just show you this real fast. So if you want to add a new service, completely new service to BPQ, all you have to do is to write a program that reads from standard in and writes to standard out. And so when you actually connect to that BPQ node to the right ID, what it will do is the first line that it sends is your call sign, right? So I'm connecting to K0 NTS. It sends ACOKQ as a line. And then everything I type and send over RF to this BPQ node shows up on standard in of this particular process. And everything that gets written to standard out shows up on my terminal and gets transmitted from RF over RF. So what I did in this case is I used N0SZ-2 as the port. In the command file, I said I'm going to add a new command port at 8004, and I'm going to have a new application that is called application number 3. I'm going to call it monitor. And when you get a connection, what I want you to do is make a connection on port 3, which is my TCP IP port. And this keyword host 0 is just magic that says it's the first program that I'm going to define. And then this is the call sign that it's going to map to, N0SZ-2 in that particular case. And then the rest here, that's the alias and the 255 is just a port packet length setting. If you then set up a system so that when there's a TCP connection made to port 8004, that it will fire up this particular process, you can go and write a program like this. So this is just a little Perl program that I wrote that basically reads from standard in and writes to standard out. And it simply interprets the commands. So if the command is by, it will say 73 and shut down. If the command is time, it'll basically just send back the time. If the command is disk, it'll just send back, you know, how much disk space I've used. But if you can think about this, you can literally do anything that you can run as a process on this computer to do this, right? You can do database access, you can do email forwarding, you can do literally anything. And so what this particular ability in BPQ allows us to do is to actually extend the capabilities of our node to do all of these arbitrary things. And so here, you know, I just connected over RF, and I asked at what time it was and how much disk space I had and so forth. So it is wonderfully extensible, and you can add all kinds of new capabilities through this, right? Because all it is a router, right? You're coming in on RF, and you're going out over a TCP connection, and it'll do whatever you tell it to do. So that's all I had. If you're more interested in this stuff, these are good references to look up. So there's a little mini how-to to set up BPQ. There's the link to BPQ. If you want to go read John Wiseman documentation of BPQ itself, there it is. It's somewhat dense, but very informative. If you want to get WinLink authorization, again, that's the same URL as John provided, so grab that one. It's an important one to have. And if you want to see all of the other talks that I have given on BPQ and WinLink, for example, I gave a talk at the New Mexico Tech Fest last week about an application I wrote that spoofs BPQ to WinLink. It's called NTS Gateway, and it's basically a way of pretending to be a BPQ station, connecting to WinLink and getting all of the NTS traffic and downloading it, right? And again, basically is a way of using the B2F protocol to connect to WinLink and download stuff, right? It's a wonderfully extensible system that may be something that you would be interested in as well. Okay, so theoretically, I still have them for 15 more minutes, right? My students hate me. So that's all I had. Thank you all for attending. Again, a reminder that our schedule for April and May is getting reversed. So the balloon flight is now in May, and the April talk is going to be on SDR. And lunch is at La Fogata, so we hope to see you there. And again, Wayne's in the background. If you want to give him something, he'll be happy to take it. Thank you all for coming.